Hello, everyone, and welcome to this Microsoft Reactor live stream event. We are live from Dubai, and I'm very excited to be joining you to be talking all about this new machine learning series that we have in April. This is the first session in the three-part series where we will be talking about machine learning for evolving applications and kind of going through everything from, AI, machine learning, like the basics, the machine learning algorithms, how you can actually get started into this field, and kind of also showing you how you can actually build a machine learning model after we've kind of, built the solid foundation of learning everything from, all the kind of theoretical kind of things, as well as, understanding all the different mathematical computations that need to be done, and, algorithms, and so much more. Thank you all so much for joining us from wherever you are in the world. Please let us know in the chat box where you're joining us from. We are live from Dubai, and my name is Hadid Shubair, and I am the Regional Cloud Advocate and Data Analytics Engineer at Microsoft Azure Middle East and Africa. Very excited to be here with you today. And today, as I mentioned, we're going to be talking. It's going to be a very kind of lovely, lightweight, beginner-friendly kind of introductory session to the world of machine learning. So before we actually begin and see what we have on our agenda today, as you all know, this event is part of our Microsoft Reactor Code of Conduct. So obviously, we're all here to learn and make this a friendly environment as much as possible. So obviously, the chat box is open for you for any kind of questions or inquiries. Make sure to ask any questions if you have any, and we'll try to answer as many of them at the end of the stream. Make sure to be welcoming, be respectful, and most importantly, be kind and considerate. That being said, let's look at, if you have never been here before, I would like to kind of introduce myself to you. So my name is Adil Shubair, and I'm a regional cloud advocate at Microsoft Reactor Middle East and Africa. I am based in Dubai, United Arab Emirates, and I am very passionate about sharing knowledge and building communities. So communities such as like women in tech communities and data analytics communities as well, AI communities, and just basically anything that is related to tech, I absolutely love. I am based in Dubai, United Arab Emirates, and if you would like to connect with me, my LinkedIn handle is on the screen. It is just like my name, Hadil Shubair, and my Twitter handle is @Shubair3. That being said, part of what we do is we go live online, just like this kind of live stream, and sometimes we even have in-person events where we kind of talk all about, everything that is kind of tech related. So my kind of areas of expertise and areas of interest that I really love to talk about are data analytics, AI, data science, machine learning, as well as kind of exploring other tech topics as well. So that being said, thank you all so much for being here, and please make sure to connect with me on any of my handles. And, just so if you have any questions after the session or such, I would love to kind of answer them. Let's look at our agenda and kind of see what our learning objectives are for today. So as I mentioned, today is going to be a very lovely, lightweight kind of introductory session to kind of introduce, extreme beginners or people who are interested in getting to understand all about the basics of machine learning. So we're going to kind of deep dive into the world of machine learning, understand, everything from the definition, the main goals of deep learning. We're going to also be exploring the different types of learning we have. So we have different types, and we need to know how we can differentiate between each one of them. And then we're going to be kind of exploring and understanding how machines actually learn. So we always hear about the term of AI, artificial intelligence, machine learning, big data, data analytics. And today, obviously, our core topic is going to be machine learning. So have you ever actually wondered how machines actually learn on their own? This is actually something that we're going to be exploring. Lastly, we're going to finish up this, topic or this session by kind of providing with some real-life examples and use cases and applications that you see being used where machine learning is actually being used. That being said, let's actually begin. So I would like to begin this session by actually asking you a question. So have a second to think to yourself, how was life like before machine learning? So machine learning is obviously this tech topic it's kind of like the hot topic of the industry. AI and machine learning, it's basically what people have been talking about, what kind of organizations and businesses have been kind of relying on to invent smart machines and smart solutions to everything they're looking for. But what was life actually like before machine learning? Now, if you can kind of like take a minute to yourself and think, so over the last century, actually the pace of technological innovation actually has increased in gradually or drastically. So over the last decade, there has been huge advances in tech. We had the rise of obviously Internet of Things, of big data, artificial intelligence, machine learning, specifically in that world of AI and machine learning as well. These changes obviously have had a growing impact on us, on our lives as human beings, and also affecting basically everything that we've been doing. So everything from entertainment to finances, personal banking, e-learning as well, and even obviously being right now in the era of having smart homes and smart devices, sensors, and all that stuff. So now let's actually go back a bit and see and look at how it all really started way before AI and machine learning. So let's go through a journey and actually talk about how the history of machine learning actually started and how this actually, term came up. So back in the 1950s, back in the days, Alan Turing developed a Turing test, and he's basically a computer scientist and a pioneer, and he developed a Turing test to actually see the difference between how machines and humans actually, if like machines can actually think like humans. So after that, they did like lots, he did lots of research and kind of started inventing new things and looking at science and all that stuff. After looking up and doing these tests and such, in 1956, he organized, there was the 1956, the Dartmouth conference, which was very kind of popular back in the days. And this is where they actually kind of developed, and kind of John McCarthy was the one who actually discovered the term artificial intelligence. So basically they started kind of, it was all kind of all cool and new back then, and they started, inventing these new little things that could do cool things, such as they had Eliza and Shaky the robots that could do some like natural language processing and some small tasks that really were a big kind of deal back then. Later on, for like 10 years, there was kind of less compute. So, there was not enough compute and such. So this is where kind of things gradually slowed down, and there was basically like an AI winter break. So after that, when came back into our homes and all that stuff, we were back to all these new technologies and kind of big data. We were introduced to big data, machine learning, deep learning, AI, and we even had also like smart and visual virtual assistants such as Siri be more involved into our homes. And we started kind of being introduced to all these smart devices, such as now we're able to kind of instead of like vacuuming out the whole house alone, now you can have a smart vacuum robot that can literally do that thing for you. So we can say that we have basically gone through a tremendous age of invention, and now we are at the age of application. So that being said, since we're at the age of application, all of this is actually, if you actually really think about it deeply, all of this is actually data driven. So we're all kind of collecting this kind of data, and depending on kind of these machines to actually work and use these data to help us make predictions, or to help us kind of be able to make better decisions regarding really anything that we're onto. And in fact, if we are not really aware yet, AI and machine learning is actually being integrated in every part of our lives now, and in every single sector there is out there. So if you think of the healthcare sector, machine learning is actually being used for drug discoveries, and even to help kind of you have also personalized nurses to help patients kind of answer any questions for the patients, and even follow up on their health, and much more. So you have the education industry as well. So in the education industry, AI is being used for to do like personalized content for students. You have also obviously, instead of having the presence of a teacher, obviously in during COVID, you had e-learning. So this is all because of the thanks to AI and machine learning. So this is basically just the timeline of how really it all started. And obviously we can say now that we are in this era of actually applying all these new cool things that were back then kind of like in science fiction movies and such. So let's look at how life was actually without machine learning versus life with machine learning. Now, for anyone who really doesn't know about AI and machine learning, they would just think that AI and machine learning maybe is just basically only used in machines and robots. But if you really think deeper beyond that, if you actually search for let's say you want to search for a specific term, you want some information on, let's say you want to, you want some information on computers. So the first thing that you go to is search engines, so such as Microsoft Bing. You would go there and you would obviously search for whatever you're looking for, and based on your search, it these search engines will kind of provide you with the best recommendations based on what you're searching for, and even more. Back in the days, imagine life without those search engines. You would basically kind of go through millions and hundreds of books and to try to find what you're looking for, and sometimes you might not even find what you're looking for. So this is just a brief example of how important it is and search engines are, and this is all because of machine learning. Also, now obviously, back in the days, you would kind of spend most of your time. So let's say you have a picture of your friends and family, and you would kind of post it on Facebook or somewhere. So back in the days, it would take you maybe like long hours and such kind of, or just so much time to basically tag every single person there is in a picture that has, let's say, more than 1,000 people. Now, obviously, thanks to Facebook and Instagram, they are, because they are AI enabled machine learning, and they have they're trained with machine learning models. They're able to kind of basically tag and the people in the photos for you. So that just makes it so much easier. And obviously, we also have speech recognition. So obviously, back in the days, we did not have these like smart virtual assistants such as Siri, Alexa, Cortana, and obviously those smart assistants that would be able to help with any kind of inquiries that you have. So if you wanted to ask about what the weather is today, you would basically have to kind of go outside and look for it yourself, or kind of have to try to forecast what it is. But now, thanks to machine learning, you're able to completely ask Siri, ask Cortana, do a quick search engine, and you will be able to find the answers that you're looking for. So this was life without machine learning. Now with machine learning being incorporated in our lives, we have all these new cool things that we're able to do. It's not like that we were not able to live without machine learning, but it just makes things easier and makes things just much more efficient. So right now, let's say you were in touch with a friend, for a few years, and then you completely lost contact of them. You lost your phone, you lost their number. So you can now use obviously social media to search for them, and then be able to connect with old friends and such. Of course, I'm pretty sure most of us and most of the viewers have used Amazon to shop, obviously for their favorite products and such. Now, obviously, with Amazon, let's say, let's have an example. You wanted to search for, let's say, a formal suit. So as soon as you search formal suits, Amazon would actually give you some recommendations or recommendation systems that would kind of give you, it would recommend such as formal ties, formal shoes, formal attire, formal, let's say, pants, and so much more. So you see where this is going. This is all because of AI and machine learning. So it could kind of basically, the machine would kind of basically take the data from you, understand and analyze what you're trying to ask for it, and give you, based on that, provide you with further predictions and such. And so much more. Same thing with Netflix. Obviously, if you go on Netflix and you search for a movie, let's say you're into comedy movies and such, the next time you go on Netflix, it will take your historical data or your historical kind of previous search, and based on that, it will kind of recommend you more movies that are kind of in the genre of comedy. So you see how life is before machine learning and with machine learning. Now that machine learning is being integrated in our lives, it's just, just this kind of exciting advancement, and I think it will only continue to grow with the the big data that we have and all these big new technologies that we have coming up as well. So let's actually define and get into it. Let's define what machine learning actually is. Let's look at the actual definition of what it is. So machine learning is just like its name, the kind of having a machine to learn on its own. So you're basically asking AI systems to have the ability to automatically learn and improve from experience or from basically past data that you give them, however, without being explicitly programmed. How this actually works, just look in front of you here at this figure. So let's say you have an ordinary system and you're good to go, and it has all the basic tasks and all that stuff. So let's so with that, including artificial intelligence, now you have all these kind of AI systems and all these, recommendations and all that stuff. And that is all because of machine learning. So machine learning is the application of AI, and it provides systems the ability to learn, to predict, and to improve from experience, however, without actually being explicitly programmed. So you're basically training a machine to kind of learn on its own. Whoops, sorry about that. Back to the slide. So, as I mentioned, machine learning helps you learn, predict, and improve from past experience without being explicitly programmed. So with machine learning, it's kind of basically, if you can think of it, so you have this, smart vacuum in front of you, or let's say you have Siri in front of you. So virtual assistants or smart robots, you're basically trying to teach them to mimic human behavior. So what we as humans want them to do, this is what machine learning is. It's the capability of machines to try to mimic human behavior and be able to actually do what we humans are doing. With machine learning, it kind of takes the approach of letting computers to actually learn to program themselves through experience. So as I mentioned, experience is a very important one. And by experience, I mean by the data that you feed it. We're going to be exploring this one in more depth as we go in these slides. And with machine learning, kind of the main aim of it is to teach the machine how to perform a specific task. It could be a simple task, it could be a huge task, so such as maybe doing some natural language processing, or even such as some maybe speech recognition or image recognition as well, or even pattern detection, for example, and providing accurate results by identifying the patterns that you have. So with machine learning, it actually learns by kind of discovering what the hidden patterns are from the data that you feed it. Now, the main goal is to obviously have or give computers the ability to learn without being explicitly programmed. So as I mentioned, it learns on its own. And the way it works is basically, obviously, in the machine learning world, it's kind of the machine learning is actually a subfield of artificial intelligence, which is all about kind of creating smart machines. But how do those smart machines actually work? They work by having all these huge amounts of vast amounts of data, and they learn from the data to help predict the future or help you make better decisions regarding your business problems and so much more. So let's actually look into this topic into more depth. Have you ever thought like how machines actually learn and such? The way machines actually learn, I like to look at it is it's pretty simple. So machines will actually learn from the past data that you feed it. So give your machine the data that you want it. It will start learning from that data. It will start to see kind of a repetitive pattern from the data. Based on that kind of repetitive pattern, once you kind of give your machine new upcoming incoming data, it will be able to kind of answer your question and basically give you the right answer and predict the output for you. So you have input, so you will input some past data. The machine will kind of analyze it and kind of find the patterns on its own. Based on that, it will give you the output. This is how it really kind of works in very simple terms. So as I mentioned, machines actually learn from data. Data is the kind of the big one here. Without data, machines would not be able to function. We would not kind of have any AI systems. There would not have been all these new big advancements and technologies that that we have today, such as the Internet of Things. Obviously, it is all about data. You have data from sensors, data from home devices, smart devices, from transport. There's so much that you could really think about, from social media clicks and so much more. So obviously, as humans, we go on with our daily lives, and we would run our errands, and maybe let's say we would hang out with our friends, and you'd go to work and go back and all that stuff. But during that day, you don't realize that like a social media click, that if you took a photo, videos, anything really that has to do with sensors at your houses, in the streets, all of that is actually you generating data. So all of that data is actually called big data because it's huge, vast amounts of data. And where does this? What do data scientists, or let's say data analysts actually do with that data? They would take all that data to train machine learning models that can help with the better decision making into making kind of further predictions or even conclusions based on the relationships and patterns they find in the data that you feed it. So this is how machines learn. They learn from the data that you give it. Let's look at an actual example here. So let's say you have an environmental conservation organization and you have some volunteers to identify and kind of differentiate or catalog different species of, let's say, a specific flowers, such as wildflowers, using a phone application. How would the step look like with machine learning? Using machine learning, the first kind of thing that they have to do, the team of scientists would first collect the data needed on the different samples of the wildflowers. After you kind of the after you collected the data, for that the next thing they have to do is they have to label the different types of wildflowers that they have with the correct species. After that, the labeled data will be processed using kind of an algorithm, a suitable algorithm that will basically find the relationship between the features of the samples and the labeled species. So the algorithm will be used to kind of differentiate each wildflower from the other depending on the different features and the relationships. Based on the results will be then summarized into an actual machine learning model, and then you can actually start by having new incoming data. So once you have new other wildflowers that have not been put before, you can actually have these new samples and put them into the machine learning model, and the machine learning model should be able to identify the correct label for the wildflower. So this is basically how it actually works. As I mentioned, you have input data. It will analyze, recognize the patterns, and based on and kind of feature extraction. Based on that, it will give you the output based on any new incoming data that you feed the model. So this is really how it actually works. So this is just kind of an animation on screen with how it actually works. As I mentioned, it would go through all these steps that I just talked about. Now, when it comes to machine learning, let's look at the different types. With machine learning, we have three different core types of learning. And these are very important for us to know and to understand in a way, because you would kind of see them, be used everywhere. So let's kind of discover what each of these machine learning types are. So we have three different types of learning. We have supervised learning, unsupervised learning, and reinforcement learning. And these, as I mentioned, these terms are kind of very commonly used, and you need to kind of know how to differentiate between each one of them, because each one of them kind of works in a different way. So what's the difference? Supervised machine learning is just like its name, it's supervised. So you have labeled data. So you'd actually give the machine labeled data that it will actually learn from. Unsupervised learning is basically the machine will try to learn based on patterns. It will try to learn on its own without any kind of training data that's available. And with reinforcement learning, this is basically when the machine is actually learning on its own completely. Let's look at some examples of each of these learnings. Let's talk about supervised learning. So let's say we require, with supervised learning, actually, we require the help of previously collected or labeled data to train our model. What does this mean? So let's take an example here. So with supervised learning, you would first provide the data set that contains, let's say, pictures of a specific fruit. So in our example here, we'll provide our data set, some pictures of apples. Then you would provide another data set that actually lets the model know that these different images of apples, so let's say a green apple, a yellow apple, and a red apple, are all actually labeled as apples. So it would actually be a known response. Based on that, it will be taken to the model. So you will actually train the model. Then you will start adding like a new set of data that was not previously added into this kind of model. And based on that, your model should give you a response. The system will be able to tell you if this fruit is an apple or not an apple. So this is how supervised learning actually works. It's all about, it kind of depends on previously collected or labeled data to train your model. Now let's move on to unsupervised learning. So with unsupervised learning, you don't need any kind of previously trained data. So you will actually kind of the model will actually basically in unsupervised learning, it will try to learn on its own using the data that you give it. So let's take the same example. So in this kind of example, let's say you have a data set that is cluttered. So you don't have a specific type of fruits. In this case, we have a collection of pictures of different fruits. So as you can see, you have, let's say, um, uh, you have pears and I don't know, let's say apples and mangoes. So you will have this kind of input data. The model will start to analyze this data that you have to figure out the patterns in it and kind of extract the different features from each of the data. Based on that, in the end, after it goes through a training model, it will kind of see a pattern and then it will be able to give you a result of three different categories. So it will categorize the fruits into three types based on each of their similarities. So you provide data basically to the system and basically let the system do all the work. This is basically what unsupervised learning is in a nutshell. Now, let's move on to the last kind of type of learning, which is reinforcement learning. And what this really is all about with reinforcement learning, it's just basically like teaching a baby how to walk, how to take their first steps, or basically you're teaching the machine to start and to figure everything out on its own. So let's take an example here. You kind of have to basically, in this case, we have a apple, as we mentioned. So you will input an apple, and then kind of basically the machine will start to give you a response. So it will try to understand what basically that is without you even labeling it. So it will tell you maybe like it's a mango. So obviously you obviously know and it's not a mango. So you will kind of give your machine feedback. So you kind of teach it that it is not a mango. So based on the feedback that you give it, it tries to learn on its own, what the actual correct one is. So it learns from the feedback and keeps that in mind. And then the next time, once you input, let's say, another image of an apple, or you input another image, another kind of, let's say, another data or another kind of, part of the same question, it gives you the right answer. It should provide you with the right answer. So this type is basically really used in, let's say, self-driving cars, such as Tesla, that we really see nowadays. Tesla actually learns on basically the data that you feed it and based on the feedback and the response that you actually give it. So as I mentioned, these are the different types of learning that we have. Here we have a summary of the different machine learning types that we talked about, as well as semi-supervised learning, which is a mix of both supervised and unsupervised learning. And underneath these, we have different, obviously, categories and different kind of algorithms for each one, which we will not be covering today. It will be covered in the next session. So stay tuned for the next session because it's very important for us to kind of understand the different machine learning algorithms that we need to know, from regression to classification, clustering, and such. Algorithms to be able to differentiate between each one of them is actually a very critical part to know in the AI and machine learning world. Let's talk about a bit more, in depth for supervised learning and unsupervised learning. So with supervised learning, the main difference with supervised learning is the data that you have is already labeled and trained. So you know what you already have. And with that, you already have direct feedback. You can already give direct feedback to your machine based on the labeled data that you have. And based on that, the machine will be able to give you the output and predict and help you with the better decision making. In unsupervised, however, just like its name, you don't have any kind of training data, so your data is completely unlabeled. So based on that, you don't have access to give it any kind of feedback. It will try to learn on its own, and based on that, it will to learn by learning on its own. It will kind of try to find and discover any hidden patterns and structures and features in the data to help find what the pattern is all about. Now, how supervised learning works, let's actually take an example. So let's say you have a you want to input your data. So with supervised learning, we said we have input data. So here you want to input your data into different images of cats. So you would have different images of different types of cats and such. So you would give, you would label them as cats and you would give them to your machine. Your machine will start to kind of, analyze, and based on that, to process what you gave it. Then, how do you know if it works? You start to feed your machine with new kind of images of other cats that you have not put before, and based on basically what it sees, based on that unlabeled information, the machine should be able to kind of categorize if those are cats or not cats. So these types of problems are suited to classification problems, where you kind of sort items or problems into categories, and regression problems such as prediction, like real value, such as house predictions, stock predictions, dollars, weights, so anything that has to do with predicting something like an actual number. So classification and regression mostly fall under the supervised learning. Unsupervised learning, however, let's take the same examples. So you'd provide the first thing you would do, the first step you would do is to provide your algorithm uncategorized or unlabeled data. So you would give basically your machine pictures of tigers and cats and dolphins and dogs. And then based on all those images, so it's cluttered, the machine will try to find a pattern and extract the different features and the differences between each, and it will start to observe and learn from the patterns that the machine identifies, and it will kind of categorize them into, let's say different groups. So this is how unsupervised learning works. With unsupervised learnings, the most common problems that it's suited to is clustering. So you have such as identifying similarities in groups and even detecting anomalies like fraud detection and much more. So hackers in banks and such. So this is how supervised and unsupervised learning works. Now, it's very important to mention that in the world of, as you get to learn all about machine learning and AI, data science, and all that stuff, you need to know what the different fields are, because some people do get a bit mixed up. So I'm pretty sure you heard the following terminologies. So you have artificial intelligence, machine learning, and deep learning. Let's actually try to differentiate and understand the different terms between each one. So artificial intelligence is the bigger field. So it is any technique that enables machines to mimic human behavior. So it enables computers to pretend to be human. Machine learning, this is a subset of AI, and this is where we go a little bit deeper. Machine learning actually uses statistical methods and computations and algorithms to help enable those machines to improve with experience with the data that you feed it, also without obviously explicitly being programmed. So this is what machine learning is all about. Then we go more deeper, we have deep learning. Deep learning is a subset of machine learning, and this is where things get a little bit complex. So this is where you're trying to find more underlying kind of features and structures that you may not know of. So anything from like neural networks, anything kind of that has more hidden and deeper layers, this is what deep learning is all about. Let's look at some machine learning applications and use cases of where we actually see, in our real world. And something that you might not realize is obviously we are being surrounded by all these new technologies and AI and machine learning. And as I mentioned in the beginning of this session, they're being enabled into every single sector and in every aspect of our life, actually. So let's look at some of the most common examples. So where do you actually see machine learning or AI kind of systems being enabled to? This is basically just some of hundreds and thousands of applications of machine learning. So autonomous or self-driving vehicles. So obviously, have you ever wondered like how does Tesla or any kind of self-driving cars actually function? So if you don't have an actual passenger or a driver who would actually drive the car, have you ever wondered how it's being actually driving, how it avoids any kind of crashes, how it knows how does the car know when to stop? This is all because it was being programmed and trained using machine learning. Spam filters. So obviously Gmail and most emails kind of accounts also, they use the spam filters to actually filter which emails that you receive from outside are spam or not spam. We have facial recognition, as I mentioned, back in the days, we did not have, this kind of strong ability of these huge intelligent AI systems to be able to recognize the faces of people, sorry, as well as their names. But now, obviously, with AI systems, all these intelligent new technologies and all that stuff, Facebook and Instagram use facial recognitions because of AI systems and machine learning to recognize the different faces in the hundreds of pictures that you provided, and it will be able to tag them for you as well. We have, of course, recommendation systems. So anything from Netflix, even search engines and such. These are very also highly recommended. Also, if you go on e-commerce sites such as Amazon, let's say, or any sites that you really shop online onto, if you recommend, let's say, if you shop for or search for a specific product, it will give you the same categories of other products that you might be interested in. So it would recommend based on the historical data that you enter. The AI system or the machine learning system will basically recommend with suggestions that would be very beneficial to you and what you're looking for. Traffic prediction, this is a very big one as well. Obviously, now we have, back in the days, we did not have these smart maps and Google Maps and all those kind of, location kind of applications that really help you see where there is traffic, if there's traffic on a specific road or not, if there's, let's say, congestion, if there is like a blocked road and such. Now, thanks to all these new obviously AI enabled applications such as Google Maps, you are able to see ahead of you when there is traffic, when traffic will be a bit in a good kind of, there's no like traffic, when there's a blocked road, when you have a roundabout ahead of you, and so much more. You're able to see kind of lots of things because this with traffic prediction and with Google Maps specifically, for example, it uses real-time data. So you're able to see live, we live in a world that uses real-time data, so you're able to see exactly what's happening today and such. We have also, as I mentioned, email spam filtering, and lastly, virtual assistants. So obviously, I'm pretty sure each one of us has Cortana, Alexa, or Siri in their homes, where you ask them to, to open the blindfolds, to check the weather for you, to close the lights and such. So these are because they are AI enabled. And the way virtual assistants work is because you would input them with data, they would analyze that data, and based on that, they would give you the outcome of what you are looking for. So when you ask Siri or Cortana to do a specific task, this is what it really does. So these are just some examples or applications of where machine learning is actually being used today. And you can only think of the thousands of different other examples that you can find, integrated into our daily lives. So let's lastly look at the machine learning process. So when it comes to machine learning, what are the actual stages or the steps, or like maybe let's say the workflow or life cycle of what it takes to actually build a machine learning model? Let's actually look. So it's pretty simple and pretty straightforward. So the way it really starts is in the beginning, you know what your goal is. So you want to train or teach your model to actually predict something. So the first thing you're going to do is you're going to input and collect and gather your data, input some old data. Based on the old data that you give your machine learning model, it will be able to analyze the data, detect any patterns and the kind of relationships between, as well as attributes and such. Based on that, it will kind of be able to predict, help you with your decision-making process and give you predictions based on the historical data that you feed them. So once it gives you that feedback, you will kind of look at that feedback and see if it's actually working in a correct way. If it's working in a correct way, that means if you have any kind of incoming new data, your machine learning model will be able to give you the correct result and the correct answer that you're looking for. If not, it will go back to a process of kind of relearning. So it will learn from the feedback that you give it. Basically, that's how it actually works. So with the machine learning process, kind of you can take these steps as let's say, as a framework for any kind of, machine learning model or example or project that you're working on. Just keep these in the back of your head as you go through the stages. So the first thing you're going to do is you are going to identify what your goal is. After you identify what your goal is with this machine learning model, so what you want your model to do. So is it a classification problem? Is it a regression problem? So do you want to try to classify two categories, like for example, cats into not cats? So you have images of cats and you want your machine learning model to actually be able to classify them. Or do you want to, let's say, predict a specific number or a specific value, such as, so that will be a regression problem. And with the regression problem, let's say you want to, predict the weather forecast. You want to predict the prices of houses in the next few months and such. So based on what your goal is, you need to collect your data. And the data, obviously, that you collect should be data that is from a trusted source. It should be reliable, and it should be something that is obviously related to what you are trying to solve at the end of it. Based now you have your data in hand. What is your next step? Your next step is to look at the data that you have in hand, and mostly the data that we collect, whether it's from online, from from if it's from any kind of format or any other source, third-party sources and such, wherever the data that you really collect from, most data sets that we have are absolutely messy. And what that means is you need to make sure that your data is clean. So you need to look at your data, make sure that the data is not kind of does not have any missing values, any null values, any errors, any kind of typos. So all of this actually has to go to a stage where you actually prepare the data, clean it, and make sure it's formatted correctly before it moves on to the next step. Or else, if you have like bad data or garbage data, you would have garbage results. So always keep this in the back of your head as you're looking into this step. And in this step, you actually look into splitting your data sets. So the data set that you have in hand, you need to split most of it into training to help your machine learning model, to train some of that data to your model, and the rest of it, like just maybe a few part of it, like a portion, like 20% or 30% of it, the rest of it will be used to actually test. So let's say you will take the data set that you will have will be split into a format of 80 to 20 or a ratio of 70 to 30. And what that actually means is you will take 70 or 80% of that data to train it, because you need most of that data to train your model. So keep in mind that your model does not know what you are trying to teach it. So it's kind of starting from scratch. So you need most of that data to actually train it, to be able to understand what you're giving it and what you're feeding it. So it will use all these learning algorithms and data to help you with the answer. The rest of that 20% or 30% will be used to test the data. Once you have new incoming data that you have not put in before, your machine learning model should be able to give you the result that you're looking for. Next, we move on to training our model. This is where you select the machine learning algorithm that is suitable for your dataset. And this is where it will actually kind of do all the mathematical computations. And this is where your model actually does everything behind the scenes to learn and develop the predictions. Based on we're done with the training of the model, the next step is to actually test the accuracy of the model. Now you need to see how well your model is trained. Is it did it understand what you're trying to teach it? Is it giving correct answers? So obviously, since you're the one who's teaching the model, you should know the answers, and based on that you should give feedback. So this is where you check the model's accuracy and kind of give it feedback. And then lastly, you would improve. So you would, based on the performance that you see, if the model is giving you the correct answers, then you're good to go. Any incoming data, it should be giving you the results that you're looking for, predictions or better decisions. If not, you can redo the process in several ways, such as hyperparameter tuning, like tuning some parameters, variables, controlling algorithms, trying different maybe machine learning algorithms to train the model. So there are several ways to do that until you make sure that your model understands everything and is able to give you the correct result. So in a kind of let's say in conclusion, this is basically, you can use these steps as a framework in any machine learning project that you build. So if you have a machine learning project that you want to, let's say, classify something into two groups, an item into two groups or categories, you have a clustering problem, you have a regression problem, whatever it is really your goal, you need to keep these steps in the back of your head and have them as a solid foundation as you move on to your steps, because each step is as important as the next one, and you need to make sure each one is done correctly before you move on to the next one, because the better you take your time with each of these steps and kind of stages, the better results that you have. So this is what the machine learning process is all about. And lastly, this is kind of the last part of what we have today. So obviously, we talked all about machine learning and all that stuff. However, if you're a complete beginner, if you're someone who really wants to get into machine learning, you want to start with building your first machine learning project, but you don't know how, here's my tips from my experience on how to get started into this actual vital field. So here I kind of summarize them to you based on my opinion. These are the most important things that you need to know. So the first thing, if you want to get started into AI and machine learning, you need to learn the prerequisites. So basically, have a kind of a familiarity in kind of programming, in mathematics and statistics, probability as well. Just kind of, make sure that you have an understanding, at least a basic foundational understanding of all, those kind of mathematical materials. And with learning the prerequisites as well, you want to kind of understand the kind of the foundations for each of the different topics that you have. So the AI world is absolutely huge. There are many topics that you need to understand, from different algorithms, different types, stages, and so much more. You can ask me, Hadid, where do I get started? There are many resources out there. Your best bets are the Microsoft Learn website that we have, Microsoft Learn platform, where you have completely free online, free kind of material for you to. Free materials for you to use based on whatever kind of level you're at. So if you're a beginner, if you're advanced, or if you're intermediate, and in any basically top tech topic that you're looking to explore, such as if you are a beginner and you want to explore data science and AI, you can just go on my Microsoft Learn platform and kind of discover that at your own pace. So Microsoft Learn platform is a very good one. Also, you can also check out our GitHub kind of site for the Microsoft also. So our Microsoft GitHub kind of also platform is very good one. We have free beginner friendly, and many other repositories and many projects that we use and curriculums that are free for you to look at to help you continue your learning journey in any topic that you're looking for. So actually, in the chat box, I'm going to be adding for you two links that we are highly recommended to help you get started into your AI and machine learning journey. So I would highly recommend you to check them out. One is a learning module, and one is a GitHub machine learning for beginners curriculum that really helps you actually get started with knowing everything you need to know for the foundations of AI and machine learning. So after you've learned the prerequisites, you will need to be familiar with a programming or coding language. So get yourself familiar. The easiest language is Python. Python is very easy to use. It's very beginner friendly as well. You can use R also, or RStudio, Java. So get familiar with a coding language that you really like. Then you need to kind of be familiar and understand the different machine learning algorithms. And this is an important one because if you're wondering, Hadil, there are many machine learning algorithms. How do I differentiate between each one? How do I know where to actually learn all of them? Don't worry, I've got you. Our next session is going to be this Thursday, and I'm going to actually at the same time, and I'm going to actually teach you everything from machine learning algorithms that you need to know. So I'm going to give you like the easiest kind of framework to help you actually learn all the machine learning algorithms that are out there, the most popular ones, how to use each one, and the difference, and even examples, giving you examples of each one to help you actually get started into your machine learning journey. Because in any machine learning project that you want to build, you heavily use machine learning algorithms. That's like an actually crucial part. So this is why in the next session on this Thursday, April the 13th, we are going to be exploring this session. So stay tuned for that one. Next, you have kind of built your framework and you learned all the algorithms, you learned your programming language. What's next? The next thing to do is to actually start practicing. So all this theoretical knowledge, you need to actually have some hands-on projects. So find some data sets that you love online. Now we live in a world where everything is free. You have free online sources. So check out, Microsoft Open Data Sets. Check out many, if you can just search for free data sets that are interesting to you, just search for them and start actually working and building your own projects. So with practice, it makes perfect. Lastly, and most importantly, I would highly recommend for you to connect yourself with an AI or machine learning community to be able to kind of meet like-minded people, as well as, be able to know of any opportunities in the field and kind of even exchange ideas on, let's say, on different projects, on different opportunities, and kind of even on, kind of be able just to be inspired. So obviously, this is something I would highly recommend for you to check out. Check out if there are any meetups in the area, or even online communities as well. That being said, we are actually done for today. So if you would like to actually continue exploring your machine learning journey and you would love to know more all about what we learned today, and you would like to get a more in-depth kind of deep dive into the world of AI and machine learning, your best two resources are on screen. So use your phone, your iPad, or your device to scan these two links that we have here, or QR codes. One is a learning module that I talked about. It is all about getting started using data science for machine learning. This is a very popular learning module. I would highly recommend for you to check it out because I usually love to use it in my streams, and it is absolutely great a resource for you to help you get started. The next one is a very popular machine learning for beginners curriculum on our GitHub also platform. So check this one out. It's a complete PDF or guide that helps you get started. It's a complete beginner's guide, actually, beginner friendly guide to help you understand everything you need to know with machine learning. So check these two links out. They're also posted in the chat box. And that being said, we are done for today. Thank you all so much for joining us. So as I mentioned, our next session is going to be this Thursday, April 13th at 3 p.m. Dubai time. So convert it into your local time zone. So as I mentioned, April 13, Thursday, 3 p.m. Dubai time. Make sure to stay tuned. We will be talking all about the machine learning algorithms that we have and exploring those more in depth to help you get an idea before we move on to the last session, which is to actually build the machine learning model. That being said, thank you all so much for joining us. I hope you had a good one, and I look forward to seeing you next Thursday. And thank you all so much for being here, and I'll see you soon. Take care, everyone, and goodbye.